In this video, we'll be solving a problem where we have to predict the outcome of a double replacement reaction, which has the generic formula A, B plus CD equals AD, yields AD plus CB. So the first step is to go ahead and write down the products. And in order to do that, we need to look at the oxidation states of the first two compounds that we start with in the reactants. So let's take a look, and if we have FeS, aqueous, and we take a look at those, iron can be +2 or +3, but since sulfide is going to be -2, iron will have to be +2 in this case. So we have a +2 charge and a -2 charge for iron. Magnesium chloride, Cl2, is going to have a charge on the chlorine of -1, and there are two of those, so we'll have a magnesium charge of +2. When we go ahead and predict this, we'll follow our generic formula up here. So AD is going to end up being Fe, or iron chloride, Cl, and since iron is going to be +2, we'll write that there, and -1 for chlorine. We'll hold off and we'll do the crisscrossing in just a second. And then we'll have Cb, which is going to be magnesium and sulfur together. Now, since we crisscross these, we'll crisscross the charges. And magnesium, again, is +2. Sulfur is -2. So we'll crisscross those and reduce them as well. So we'll end up with FeCl2. Plus MgS, since the 2 and the 2 are going to come down, but they'll cancel each other out, so we have MgS. The next thing is to balance the equation, so let's do that together. FeS plus MgCl2 yields FeCl2 plus MgS, and since we have one iron on the left and one on the right, those are fine. Sulfur, we have one on the left and one on the right, that'll be fine. Magnesium will be on the left, it's going to be 1, and on the right it's going to be 1. And chlorine, we have 2 on the left and 2 on the right, so it just so happens that this is already balanced for us. But if it's not, then we go ahead and we follow the generic balancing rules that we have to follow. Okay? The final step here is going to be predict, which equation is going to be, or which part of the equation is going to be insoluble. And so we'll have to look at the solubility rules. Specifically, we'll have to look at table E. Okay, and if we look at table E will tell us that chlorides, if we look at this guy, are going to be mostly soluble. And there are a few exceptions, but iron is not one of them. So we know that iron chloride has to be aqueous. Okay, and then the last one here, the magnesium sulfide. Okay, Mg is not going to matter so much, but the sulfide will. If you look at sulfides, these guys are going to be insoluble. And there are some exceptions to that, but there are none that we need to use here. Okay, so let's go ahead and let's just rewrite this as the final conclusion. I'll do that in red so that we have this correct. So we'll end up with our final reaction being FeSAQ, since both of the reactants are going to be aqueous, plus MgCl2 aqueous yields FeCl2 aqueous, should be a little Q there, plus MgS solid. And that is our balanced double replacement reaction.